Hello Godosians, Andy here. In this video I will be creating a custom class in Godot, and it will be to provide a shape data. So we're going to call it shape data, our custom class. What we're going to do, here we are in the scene, 2D scene, so we want to be in the scripts, and we're going to add a new file. We're not going to make a new scene, we're going to make a new file, and we're going to click on new script, and let's have a look here. Empty template, yes, and let's call it, give it the name of our shape data class that we want. Shape data, and create. Alright, so it extends node. Now I've got a confession to make. I've already been through the process of coding this stuff. In fact, 2 days worth of it. What we do, we start off with our initial ideas. Like when you're making a game or something, writing code, you try things out and it's really clunky, you know, kind of full of bugs, and what we do, we refactor, like we change our ideas and we try new things and we condense it down into something that looks really neat and works very well. And that's what I've already done over the course of 2 days and many hours. So obviously I don't want to document the whole process of me doing that, because it would be like a game jam video, you know, when it lasts many hours. So this is the result of, you know, a lot of work behind the scenes, teaching you what I think is the best way to do this thing. Okay, so with that out of the way, to start with, we are extending a node. Well, I found that extending a node, that's very basic, and it doesn't really work that well. So instead of extending a node, I extend a control. What this means is it's like inherits all the features of a control and the methods and properties of a control node. And it's just some problem I had when I was using the duplicate method to make a copy of an object. With node, it just didn't work properly. You know, it wasn't copying everything across. So I ended up with, and anyway, I'm using controls a lot here, and it seems like a natural thing to extend from the control. Alright, so the next thing to do is to give the class a name. So we type class name and then the name of our class, and we're going to call it shape data in Pascal case, which is the proper way to do it in the way we do things in Godot. So we call it class name shape data, and this will, just doing that will make our class available in the autocomplete. We will see it appear as a known or recognized class, even though it's a custom one, in the other scenes and our scripts that we make. And you know, if you forget to do this, you know, you create a new class and then you didn't see it coming up, and the autocomplete's not working, you can like do this again, you know, cut and paste this and like delete it and Control Z, Control X and Control V, and then that will kick the engine into recognizing it again. That's one of the things I came across when I was, you know, going through the iterations of, you know, the recoding and stuff. Anyway, we have defined the shape data. We might as well save it. Control S. Save it. Okay, it's a resource. They call it resource. Why is that there? Control S again. A root node is required to save the scene. Okay. We're saving a file. It's not a scene. Let's see what can we do? Save. Oh, okay. Yeah, Control S is saving a scene. So I did a right click on there on the actual file name in this list and then saved it. I've made that mistake a few times before. Alright, so let's add properties that we want to have. We make those with the var. These are going to be public properties, so we just use names like we're going to have a color. This is like the shape data, right? So we're going to have a color for it. The thing is, this will be used game-wide, so there's one aspect is the visual shape that is displayed as it's falling down the grid. This is the Tetron, by the way, the Tetris derivative, Tetris-inspired game. So we can have a visual thing, and then behind the scenes, you know, when the shape places itself, it gets locked into the grid. We're going to need to know what color is it, you know, what shape is it, and that kind of thing. So this is what these parameters are for. So let's, rather than leaving them blank as nulls, let's put in the actual type, data type that they are. So color is obviously color. And the var next, we're going to have a grid. The grid will store an array of the shape itself, like which it might be a square array, a grid representing the area that the shape covers, and then true or false values representing is there a cell in that place or not. So I've gone, let's just type that correctly, grid. So we got a grid, and then the next property, the next public property, coordinates. I'm going to just type cores because it's simple, easier to write. And that'll be an array, a one-dimensional array in this case. This will define the, yeah, okay, let's bring in our technical design documents on GitHub. So you can see that we have local grid coordinates. They might be in range from -1, 0, 1, or -2, -1, 1, and 2. And it's the same for x and y. So we are gonna store these values in a one-dimensional array for use later. So these are the cores array. And then we got var. Next one we want to have is the cells themselves. This will be like copied and duplicated from our visual grid container that we had before, which we created in the scene of our various shapes. So let's put that in there. Okay, that is our class. So we can go shapedata.new in our other scripts to create a new shape with these properties. So we're going to add some functions that will apply to shapes, like we're going to rotate them left and right. So let's start out with a rotate left function, or method if you like, because classes have methods even though these are functions. So rotate left, let's just put pass in there for now, and then another function, obviously rotate right. So put that in there, right, rotate right, and pass. Now moving on. Now, well, like I said before, there are two things. There's the visual shape that is on the screen that's dropping down, and then after that it's going to be, when it's hit the bottom, there's nowhere further to go, it's going to be locked into the grid. So we're going to have like the visual one that's moving down, and it's actually going to be parented to a node 2D that moves it down the screen visually, and it can be rotated easily around the node 2D. And there is the cells information here stored in this shape data object. And that is another thing, that these cells need to be rotated as well. They're like the virtual cells, if you like, in the background. So let's first of all, in the rotate left, let's put in some code to rotate the cells to the left. And the visual cells, I should say. So how would we do that? We're gonna F10. Right, so in here, the cells, these are the grid container, which is the visual cells, and the grid is the virtual cells. Okay, so to rotate the visual cells left, we're gonna just access them because they're a grid container. They can't be rotated because they're in the grid container, but the node, their parent node, is a node 2D, so which can be rotated. So we need to access, get parent. We need to get the parent of that. It's okay to do it like this because this is not a scene. It is a class, an object related to the scene. So we're gonna do that, and then we're gonna rotate. All right, so we're gonna get the parents, and then we're gonna rotate. And this rotate method uses radians. So in a circle there are 2 pi radians, and we want to rotate in steps of 90 degrees. So there's 2 pi radians in a circle. 90 degrees is a quarter of a circle, so we are using the built-in constant of pi and dividing by 2 to get 90 degrees. And left movement is minus 90 degrees. All right, so then we can copy and paste this to the next function for rotate right, which is the other way around. So yeah, that's going to be the positive version of that. And now what we're going to do is we're going to have to rotate the grid, which is an array, a 2D array, so it's a bit more tricky. So in this case, we will have a local function, which we call in object-oriented programming terms a private function. So we use underscore for the name before the name, prefixing the name, underscore rotate grid, because we're going to rotate our grid array. There we go. So it's going to be a function doing that. Let's define our function. Let's do it there, func, and then pass. All right. And one thing I picked up recently, which I haven't been doing, is in Godot we're supposed to have 2 spaces between our functions, because when we got a long body in the functions, we sometimes space things out with 1 line. Then to separate the functions, you should use 2 lines. So let's get that right from the start. All right, so now, yeah, let's have a look at our documentation again. Let's find it. There it is. So in our I mean the technical design document, it says we're gonna rotate clockwise by transforming the x coordinate in this way to rotate clockwise. Okay, so we will move the minus y x coordinate or position into xy. And similarly for anti-clockwise, basically we're going to exchange x and y. You know, this is x, this is y. We're going to exchange them. And in one direction, one of them is made negative, and the other one is made negative. So we got x and y. This is a little bit, maybe I'm not explaining it very well, but the fact is that to make this sound, we're going to use well-named input parameters. So we want to know what is the sign of the x, what is the sign of y. So we will have these input parameters, sign of x, sign of y, coming into our rotate grid function. And up here we're getting this error because now we've got input parameters that we have to put in. They happen to be 1 and -1. Like I said, I've already coded this before, developed it. So what that means is x and y. X is plus and the y is minus y. Okay, we're gonna, and then this one, let's cut and paste this. It's the other way around for the other rotation. So we're going to have -1 for that, minus x, and then +1 for plus y. And then in our function for rotation of the grid, we're going to start off, we're going to make a copy of the existing grid. We call it rotated grid. And later we will replace the actual grid with the rotated grid. So now this line here is copying the grid, existing grid. We use the duplicate function, and it has a optional input parameter of do you want to go deep or not. Because it's a 2D array, I've put true, yes, let's go deep. Even though we may not need to, but it doesn't hurt to include that. You could, it's probably a good idea to debug it and on the next line, check what did it do if you compare between using true or not having true. By default it's false. So if it's false, it may only copy like one level of the array, I don't know. I think you don't need true, but I've left it in anyway. So we got our rotated grid, which is a copy of the existing grid so far. And now we're going to proceed to scan through the columns and rows of the array. It's a two-dimensional array, okay? So we're going to go x. We can have a, like, imagine we're going left to right in the coordinates. The coordinates are, I should bring that up again because it's an important thing. The coordinates are like this. We created them in our shape scene. Like they are like not necessarily the same. They're -1, 0, 1, -2, -1, 1, 2. And so forth. This was covered in a previous video. So this is looping through them, the one-dimensional like coordinates array, which is the same for x and y because each shape is contained in a square array. So we're going through them there in the x, and we're gonna scan the y as well. So we're gonna create values for x and y over the square space. And then we will need to map these because the final array, the indices of the array only go from 0 to the size of the array -1. So like 0, 1, 2, 3, 4 and so forth. Not a -1, you know, 0 plus 1 like that. So we're gonna have to map them over. So I'm gonna cut and paste the code I've done before rather than type it all out again. Here we go. So we've got the x1 is the one we're gonna copy to. X1 and the y1 will be the rotated grid coordinates, and then we're gonna come from our existing grid, which will have coordinates of x2 and y2. So to transform, to map the coordinates which are like -1, 0, plus 1, we look for their position within the coordinates array, and then that will give us the actual, like, it'll map -1 to 0, for example, and 0 to 1, and +1 to 2, that kind of thing. So that'll give us the correct, like, index into the array for where the actual cell is. So we're going to, like, the equivalent of the xy for the destination of the rotated grid, and then we're coming from the place which is specified in our way to rotate. So x is going to be replaced by the -y for clockwise, and y will be replaced by x. And then similarly it's the other way around for anti-clock, so x will become y and y is -x. So remember that clockwise rotation, x is -y, y equals x. So let's quickly go back here. So x2 is where we're coming from, so we're going plus or minus. X is always going to be replaced by y, but plus or minus y. Y will always be replaced by x, but plus or minus x, and we're feeding in the values there as to whether they're plus or minus, and they're the other way around, minus and plus. So that may be a bit tricky to get your head around, but you know, that's a pretty easy way to do it. Then finally, we've got our coordinates, so we will. By the way, this is called logic design. You know, you game logic. You have to figure this out. You know, write stuff on paper and figure it all out. So this is the actual copying of the cell data across. The data, I mean, they're just like true false values as to whether there's a cell in that like grid position or not. So we're copying from the grid to the rotated grid for each of these x and y positions. So the next thing is to, after we've done all that, we're going to copy, we're going to write those values over. We're going to, because the rotated grid is a new object of an array. It's got like a reference, and we just assign that now to the grid, so that becomes the new grid. So in the next video, this is the shape data class, and in the next video we will make use of it and show you how to, we will actually make a shape scene. Well, we've got that shape scene, but we will attach the shape script to it and then make use of this shape data class, creating objects of shape data, and finally test what we've done in a test scene. So I look forward to showing you all that in the next video. Okay, see you again. Like and subscribe if you can. Bye bye.